Welcome to this video of how to use Mathematica in multivariable calculus. In this video, we will see how to find the domain and range of a function of 2 or 3 variables. We will use the Mathematica notebook as our presentation interface. These videos are intended for those who have a basic or no knowledge of the Mathematica program, but should have some basic notions on calculus. The design of the notebook you are seeing, I have selected it from Format, Style Sheet, then Style Sheet Chooser, and from here you choose the one that you like most, or you may work with the default one. Here we have the list of exercises that I have previously written and some definitions we will consider later. For these exercises, determine the domain and range of f. In exercises C and D, plot the region defined by the domain of f. Well, as we want to find the domain of a function, we will start by typing domain. So we may do this here. Once the cursor changed to a horizontal bar, you start typing and automatically Mathematica generates a cell, an input cell. It is indicated by this kind of bracket on the right of the screen. Mathematica will evaluate input cells. So here I type domain and then you press F1 or you go to help, find selected function. Here we are interested in function domain. And then the third entrance is the one that is appropriate for us. Function domain finds the largest domain of definition of the mapping funds of the variables bars. And what is the domain of definition of a function? Let's consider the definition I have written in the notebook. Here it is. Suppose that to each element A of a set A, we assign a unique element B of a set B. The collection of such assignments is called a function from A into B. Frequently, a function is represented by a formula with equation B equals f of A. The set A is called the domain of the function, and the set B is the codomain. In the case of functions of two variables, the element A is commonly the pair xy, and if the function has equation set equals f of xy, then the element B is set. So coming back to the question, what is the domain of definition of a function? It is the set of values that the variable or variables in this case may take. In the syntax Mathematica gave us in the documentation center, here it is, there is a third argument after bars, here, dom, that it refers to the domain where the function is defined. This is, possible values for dom are reals and complexes. The default is reals. If dom is reals, then all variables, parameters, constant, and function values are restricted to be real. So let's start by solving the first exercise. Let's type function domain. It disappeared, here it is. Let's start, I was saying, not there, but below the A that I have written previously, here. Function domain. When you start typing a command, it will appear a pop-up window and it will be selected the first entrance, in this case, function domain. Once it is selected, you press enter and you don't have to finish typing. So function domain, in between brackets, the function, and then the variables. It is 25 minus x squared. I will form the square with the palette classroom assistant. You select palettes from here. And once you have the palette, I will click there, you click on the icon of superscript. So 25 minus x squared, and then the variables x and y. I forgot the comma, that's why it appears the red hat there. Here it is. Well, this is a Mathematica input cell. Unlike the cells where I typed text, for example, the definition is on a text cell. And well, Mathematica will evaluate it. Before getting the answer, it is easy to see that the domain of this function is the set of all pairs x and y in R squared. Let's see what Mathematica gives us. And the answer is true. Well, this means that the domain is unrestricted. This is the domain of F is made of all pairs x and y belonging to R squared, as we said before. Another thing to notice is that we didn't add reals after the variables. Here, remember that in the definition Mathematica gave us in the documentation center, we had the first argument, the function, then the variables, and then DOM. Well, it is not necessary to write reals because by default, Mathematica works under reals. But if you type, you see it is the same. What about the range of F? So first, let's revise this definition. The range of a function is the set of all the images of the function. This is, if f is a function defined from set A into set B, then the set of all numbers f of A, where A belongs to the domain, is the set, is the range of f. Well, so as the domain of f was found with function domain, we would expect function range to be the command for the range of a function. Let's start by typing it then. Function range, here it is. If we go to the I there, we click there, and we consider the definition that is most appropriate for us. The one that says that function range finds the range of the mapping funds of the variables x bars, returning the result in terms of y bars. This is the third definition because we are with function of two variables or three variables. In our exercise, x bars refers to the independent variables, in this case, x and y. And as the function f has equation f of xy equals 25 minus x squared, and as f of xy is equal to z, this is Rb in the definition of function given, here it is, then y bars refers to z, meaning that we want the result in terms of z. So to find the range of f in the first exercise, we write function range. I will copy the function. I forgot the 2, doesn't matter. And I want the result in terms of set. Shift and enter. Well, here it is. The range of f is made of those sets that are less than or equal to 25. As we can see, x squared cannot have negative values, meaning that the least possible value for x squared is 0. So the maximum possible value for a set will be 25. This results in a set of values for z less than or equal to 25, as Mathematica gave us. I would like to write these two results, the function, the domain of the function, sorry, and the range as text formally. So to write the domain, we press Alt and at the same time 7. This is a shortcut to generate a text cell. And there I type domain of f equals, it is a set. So it goes in curly braces. In between brackets, the pair xy belongs to symbol from typesetting menu. Here I click from that. The belongs to, here it is. Reals from here. It is not reals, but r square. Okay, this is the domain. As the domain is unrestricted, it is made of all pairs x and y belonging to r squared. Finally, I will write the variables in italic. Here it is. With respect to the range, I will write range of f. Let's see. And here I start modifying. Range of f. It is set belonging to r, not r squared. And there is a restriction such that we can write a comma. Set is less than or equal to 25. And again, the variable in italic. Here we have written the domain of f and the range of f as if we were solving the exercise on text. Okay, well, now let's find the domain and range of the second exercise. Think of the restrictions you may have on x and y. The function is 9x squared plus 4y squared. Then let's analyze Mathematica results. As x and y are not restricted, the domain, again, should be all r squared. And with respect to the range, as x squared and y squared cannot have negative values over the reals, the range will be the set of non-negative values of set. Let's see. I will copy and paste the syntaxes from the previous exercises. Copy, paste. Function domain, I change the function. 9x squared plus 4y squared the variables x and y, you can omit reals. I leave it because it was there. And here I will copy the same. Function, here it is. Shift and enter at the same time. Good. Well, in the third exercise, we have a different thing to do. It says, plot the region defined by the domain of f. We will find the domain and the range, but we will also plot the region defined by the domain of f. So let's start. I will copy from the previous exercise, paste below. And I change the function. It is the square root of y minus x. Here it is. As the argument of the square root must be non-negative, we see that the domain is what we expected. This is the pairs that are in R square, such that x minus y is less than or equal to 0, or equivalently, y minus x greater than or equal to 0. But how to visualize this part of the region of the plane? Well, to achieve this, we will use the command region plot. So we will start typing region plot below here. We go to the eye, we click here, and it says that it makes a plot showing the region in which pred is true. And pred refers to the predicate. The predicate could be any logical combination of inequalities. In our exercise, the inequality is given by the result of the domain of f. And here we have variations for x and y, from an x minimum to an x maximum, and the same for y. So let's see how to do it in our exercise. Region plot, and we will copy the function, comma, and the variation for x and y, where we want the visualization of the domain. We want it in a square defined by x in between -4 and 4, and y in between -4 and 4 too. Here it is. Shift and enter. We are not seeing the region because I made a mistake here. Instead of copying the region, I mean the domain, I copied the function. So here I should write the inequality that defines the domain. That precisely is x minus y less than or equal to 0, not the function. Solved. Here it is. Well, and if one wants to add a legend to clarify that the region shaded, I mean, the blue region is the wanted one, we should type the following. I will copy this cell, and I will paste below. Here, after region plot, I will type legend it. I will click directly on the eye to see what legend it does, and it displays expression with the legend leg. If you notice, legend it has two arguments. In the first one goes the expression. In our case, the expression is given by the inequality of the domain. And after that, a comma, I will close the bracket for not confusing with the region plot command there. After the comma of the inequality, it goes the expression. And I want, it goes the legend. In this case, is the same expression, the same inequality. Here it is. It indicates that what is in blue is x minus y less than or equal to 0. As I was saying, in the second argument of legend it goes the legend here. I could write y minus x, that is equivalent to the previous inequality greater than 0. And you will see the same, but the legend written in a different form. Okay. Well, so for this exercise, let's find the range that we didn't. So copy from here, paste below. And here, root of y minus x. Well, the range of this function is made of the set greater than or equal to 0. Well, finally, we have exercise D. This exercise is a little bit more difficult. D is the last exercise of functions of 2 variables. Then we have one of functions of 3 variables. So in this exercise, we notice that there is a function that is fraction. So the denominator cannot be 0. Besides, there is a square root. And in general, a square root, the argument should be greater than or equal to 0. Well, combining these two restrictions, we will have a domain. Let's ask Mathematica. So function domain. One over root of fraction x squared over 4 plus fraction y squared over 9 minus 1. And here it is. The domain of f is the set of pairs x and y such that 9x squared plus 4y squared is greater than 36. Here, we should distinguish in between the boundary of this region, and the interior of this set. In this case, the boundary is not included in the domain of F. By boundary, we mean the equation of the ellipse, given by 9x squared plus 4y squared equals 36. Let's write this formally. So remember, you generate a text cell with Alt and at the same time 7. And here we write boundary of F, boundary of domain of F. You can abbreviate domain as DOM. Boundary of domain of F equals, in between curly braces, it is a set. I could copy it, or at least the first part, from a previous entrance here. There it is. And the restriction is that 9x squared, I will copy from here and paste below. 9x squared plus 4y squared greater than 36. So we have written the boundary of the domain. No, it is not the boundary, it is the domain. To have the boundary, we need an equal there instead of greater than. Yes, that is the equation of the ellipse, that is the boundary of the domain. To clarify that this curve is not part of the domain once we have the drawing or the visualization of the domain, we should have it drawn with dashed lines. Yes, in calculus, when a line is not part of the domain, I mean, it is the boundary is not included in the domain, you draw it with dashed line. And for this, we have an option in Mathematica that is boundary style. So let's first copy region plot from here. We are doing this, so what I have written should be below the D here. So region plot, legend it, and here, this is the inequality that I want to represent. And this is the legend, the same inequality. Well, as I was saying, this boundary is not part of the domain. So we should have it with dashed lines. We add the option boundary style. Boundary style dashed. And here we have it. Now we can see that the domain of the function is given by the shaded region, but of course we see the part of the domain restricted to the square that goes from -4 to 4 on both axes. We could interpret it as an open set if we want, and we are seeing just a portion of the domain. Okay, Well, to end with this, we will find the range of this function. So function range, I will copy from above. I will order this. Function range. And I need the third argument, that is set. And it says it is set greater than 0. Well, the last exercise, E, is a function that depends on 3 variables. Let's see, I will copy here. It is the exponential function raised to e to that polynomial. 3 variables polynomial. So, in this case, there are no restrictions on the variables, meaning that any value you give to x, y, or z, you will obtain a real number of the polynomial. Then the exponential function is defined for all real values and the result is a positive real value. Let's ask Mathematica about the domain of this function. So function range, function domain, sorry. And here I paste, and the variables are x, y, and z. Ah, another mistake. X, y, and z. True, meaning that the domain of F is made of all triples x, y, and z belonging to R cube. And the range, as it is exponential, we expect that it is the variable that defines that function. That could be u, because we have used z, so u greater than 0. Let's see. Use u. Okay, u greater than 0. Well, this has been all for this first video on domain and range of multivariable functions. Hope you have enjoyed it, and thanks for watching.